Since the derivative of arcsine u is u prime over square root 1 minus u squared, that means our integral of u prime over 1 minus u squared under the square root is going to be arcsine u plus c. The derivative of arctan u is u prime over 1 plus u squared, so that means the integral of u prime over 1 plus u squared is arctan u plus c. In more general terms, or if 1 is not your constant, instead you have some other constant, here are our formulas. Since the derivative of arcsine and arccosine only differ in sign, we don't need to memorize another integration formula. To integrate number 1, it looks like it might be arcsine, but let's make sure we have all the components we need. This would be a squared. This would need to be u squared, making a 2 and u x. So u prime is 1. Do we have u prime in the numerator? Yes, we do. So our integral is arcsine of x over 2 plus c. This one looks like it might be arctan. Since u is a function of x, this would be u squared, making this a squared. You could move your dx to the end of this fraction and know that your numerator is just a 1. So a is 5, the square root of 25. U is 2x, the square root of 4x squared, making u prime 2. Do we have u prime in the numerator? Not quite, but we can put it there by multiplying 2 inside the integrand and 1/2 outside. And when we multiply 1/2 and 1/5, there's our answer. Number 3 looks like it might be an arctan one. So our function of x would be u squared. This would be a squared, and we're looking for u prime to be in the numerator. A would be root 3. U is 2x, making u prime 2. Okay, we have u prime in the numerator. We just have too much. We have 2 times 4 in the numerator. So I'm going to take a 4, factor out a 4 from the integrand, so that now my numerator is 2. Now the integral is 1 over a arctan u over a. You do not need to rationalize either of these denominators. Number 4 looks a lot like number 3, but the numerator has an extra x in it. What if this one is u prime over u? If our denominator is 3 plus 4x squared, then u prime is 8x. It is u prime over u. So our integral is ln absolute value u plus c. Take off that absolute value if you don't need it, and you don't need it because there's no possibility that this argument will be negative. Number 5 also looks like number 3 and 4, but it has another x in the numerator, making the degree of the numerator and the degree of the denominator the same, so we need to use long division. Now when we integrate this one, I think we do have another arctan going on. So u squared, a squared, and we need to make sure that u prime is here. All right, we have 6 in the numerator and we need 2 in the numerator, so I'm going to factor out a 3. In fact, I'm going to do that in this step. For number 6, I don't have u prime over u. The closest this looks like is maybe arcsine, but arcsine doesn't have multiple things in the numerator. So what I can do is separate this into 2 fractions. I can use reverse chain rule for the first integral, and the second integral will require arcsine. Here's our result after simplifying. Remember that a perfect square trinomial is in this form, so what we're going to do is complete the square in order to use a formula that we've already learned. For my denominator to have a perfect square trinomial in it, I would need to take b, which is 4, and divide it by 2, and then square that. That is what needs to be added to x squared plus 4x. But if I'm adding a 4 to the denominator, I also need to subtract a 4. That way I'm not truly changing the problem. I'm just manipulating parts of the integrand. It would also be sufficient to just split the 8 into plus 4 plus 4. Factor your perfect square trinomial. Then combine the two terms that did not make up the perfect square trinomial. Now I think we might have an arctan formula. If this is u squared and this is a squared, then u prime is 1, and that's what we have in our numerator. So the answer here is 1 over a arctan u over a plus c.